Question 8. We have here 5 cards with dots. Okay, the diagram shows 5 cards. In part A, Donald chooses a card at random. Write down the probability that the number of dots on this card is an even number. We have here this 2 an even, this 4 an even, and these 2 in these 2 cards are even also. So we already have 4 cards which have even numbers. So this probability will be 4 over total 5. Okay, 4 cards have even numbers out of total cards 5. Write down the probability that the number of dots on this card is a prime number. Prime number we have here, this 3 is prime, 2 is prime, this 4 not prime, this is composite number. Okay, we will ignore. 2 and 2 are also prime numbers, so we already have here, we again have 4 cards with prime numbers. Okay, 1 2 3 4, 4 out of 5. Okay, in part B, Donald chooses 2 of the 5 cards at random without replacement. Okay, he works out the total number of dots on these 2 cards. Find the probability that the total number of dots is 5. The total number is 5. Okay, 5 is 4 plus 1, but we don't have here a card with 1 dot. Okay, so we will ignore 4 plus 1. And 5 also is 3 plus 2. This 5 here is 3 plus 2 or 2 plus 3. So we can imagine that, or we can say that if the first card with 3 dots, we will choose the other card with 2 dots, or we will inverse it, the first card with 2 dots and the second card with 3. Okay, let's suppose that the first card is with 3 dots. Okay, here we have only 1 card with 3 dots, so the probability that the first card with 3 dots is 1 over 5. Okay, 1 over 5 times the second card will be 2, and we already have 3 cards with 2 dots here. Okay, don't forget that we already take 1 card and we didn't replace. Okay, so the probability that we choose a card with 2 dots here is the number of cards here is 3 out of total now is 4, not 5. Okay, because we didn't replace the card we already chose in the first try. Okay, 3 over 5 over 4, sorry, plus. Okay, now suppose that the first card is 2 not 3 with 2 dots. Okay, 1 2 3, suppose we already choose this one here, 1 2 3, 3 out of 5. Okay, 3 out of 5. It's better to put brackets, times, and the second card will be 3. Okay, we have 1 card with 3 dots here, and don't forget we already took this one. Okay, now this 3 only 1 card, 1 out of 4, 1 over 4. Okay, equals 1 times 3 is 3, 5 times 4 is 20, 3 over 20, plus another 3 over another 20, so is 3 plus 3 is 6 over 20. Okay, 6 over 20. In this part here, find the probability that the total number of dots is an odd number. Okay, odd number, our cards here, we can choose 3 plus 4. 3 plus 4 is 7, odd. Or we can inverse it, 4 plus 3, okay, or we can choose 3 plus 2 or 2 plus 3. So we can write it here like that. This probability equals p 3 plus 4 plus p 4 plus 3 plus p 3 plus 2 plus probability of 2 plus 3, okay, 2 and 3 or 2 plus 3, it's okay, equals 3 plus 4. We have only one card of 3, so the probability is 1 over 5, okay, times we have only one card with 4 dots, so will be 1 over 4, because we already took one card before in the first try, okay, or in the first withdraw, plus 4 over 3, 4 plus 3, 4 is one card, 1 over 5, times 3, also one card, so 1 over 4. We can notice here that we can make it as 2 times 1 over 5 times 1 over 4, okay. We will complete here. P 3 plus 2, 3 is one card, so 1 over 5 times the 2, we have 3 cards with 2 dots, so 3 cards is 3 out of 4, okay, 3 over 4 plus P 2 plus 3, 2, we have 3 cards with 2 dots, so 3 out of total is 5, 3 over 5 times, and we have one card with 3 dots only, so 1 out of 4. Also we can note here that 1 times 3 is 3 over 20, and here also 3 over 20, so we can write it like that, 2 times 1 over 5 times 3 over 4, this equals 1 times 1 is 1, 1 over 20, multiply by 2, 2 times 1 over 20 is 2 over 20, plus 1 times 3 is 3, 3 over 20, 3 over 20 times 2 is 6 over 20, so 2 over 20 plus 6 over 20, 2 plus 6 is 8, so the final answer will be 8 over 20, okay.